We're going to learn about more multiplication properties, but before we do that, we need to check the skills that we're going to need. So we're going to rewrite each expression using each base only once. So we're going to look at 3 squared, 3 squared, 3 squared. So we're multiplying 3 squared times itself 3 times. So our base is 3 squared. That's the base. The base is 3 squared. That's supposed to be a highlighter. Our base is 3 squared. Once, twice, 3 times. So our base of 3 squared is going to be multiplied by itself 3 times. And that's it. So what's our base in the next one? 5 to the 7th, 5 to the 7th, 5 to the 7th. Remember, exponents are repeated multiplication. So our base is 5/7. And how many times are we multiplying 5/7 times itself? Well, we're doing that 3 times. So that would be 5/7 raised to the 3rd power. Now we've got 2 cubed times 2 cubed times 2 cubed times 2 cubed. What's our base? Our base is 2 cubed. And how many times are we multiplying that? By itself. If you said 4, you are correct. 2 cubed raised to the 4th power. And our last one, what is our base? Our base is 7, and we're multiplying 7 times itself 3 times. So notice how I kept writing the base in parentheses, and I'm going to continue to do that. X cubed times x cubed. That would be x to the 6th power. You retain the base, you add the exponents. Let me show you. You keep the base and you add the exponents. That's x to the 6th power. So this first set said rewrite using each base only once. This next set says actually go back and simplify. So this was from our last lesson, E3. So this is the rule from E3. The rule from E3 said a to the m times a to the n is equal to a to the m plus n. A squared times a squared times a squared, we retain the base, we add the exponents, 2 plus 2 plus 2, which is 6. Y to the negative 2 would be y to the negative 6. And then of course when we simplify that, we make our exponents positive, so we'd have 1 over y to the 6th. And our last one, n to the negative 6. Negative 3 plus negative 3 is negative 6, and that would simplify to be 1 over n to the 6th power. So that's a nice little warm-up. Make sure we've got it from the last lesson. Now let's talk about a new rule. Our new rule is a power to a power rule. So when I have a power to a power, I have a base raised to a power, and then that is raised to another power. That is equal to the base of a raised to the m times n. So we're going to multiply the exponent. A power to a power, you multiply. So one base, power to a power, you multiply. However, the same base written twice, you retain the base and you add the exponents. That's our multiplication property. So this is our multiplication property. And this one that we're going to work on next is our power to a power property. So 5/4 raised to the 2nd power. That's the same thing as 5/4 times 5 to the 4th. 5 to the 4th times 5 to the 4th. And we know that you keep the base and you add the exponents. So this is using the multiplication property right here. However, I could shortcut this and I could go straight to 5 to the 4 times 2, which would be 5 to the 8th power. And that's using our power to a power rule. And the power to a power rule comes in real handy because here, instead of having to write n squared times n squared times n squared times n squared times n squared, and then adding 2 to itself 5 times, we can just multiply. Repeated addition is multiplication. 2 times 5 is 10, and that's where we get n to the 10th power. N to the 10th power. So here's some more examples. We're going to simplify x cubed to the 6th power. X cubed to the 6th power. This is the power to a power rule. So that's going to be x to the 3 times 6 power, which is x to the 18th power. Okay, you try the next one. A to the negative 4 raised to the 7th power. A to the negative 4 raised to the 7th power. And that would be the same as a to the negative 28. However, negative exponents, we need to make those positive. So it would be 1 over a to the 28th power. Hopefully you're feeling pretty good about this. Go ahead and try the next one. X to the 4th raised to the 3rd power. X to the 4th raised to the 3rd power is the same thing as x to the 12th. Most excellent. Okay, here we have x to the 5th times x cubed raised to the negative 2 power. So x to the 5th is not raised to a power. It's going to stay. But then we have x cubed raised to the negative 2 power. That's the power to a power rule. Power to a power rule. So that's going to be x to the negative 6th power. 3 times negative 2 is negative 6. And now we use our multiplication property. And the multiplication property says keep the base, add the exponents. 5 plus negative 6 is negative 1. And then we rewrite that with a positive exponent. So x to the 1st power goes to the denominator. You can keep it 1 over x to the 1st, or you can simply write 1 over x, whichever one you like. Here's another example. X to the 4th raised to the 3rd power times x to the 5th. Here we have that power to a power rule. So we're going to take care of that first. Power to a power is going to be x to the 12th, and then we're going to multiply that times x to the 5th. This is the multiplication property in which you keep the base and you add the exponents. 12 plus 5 is 17. So that simplifies to be x to the 17th power. Okay, here is one for you to try. Let's make this a try. Go ahead and try this one. And when you're ready to check your answer, come back and we'll give you another try. Okay, if you started working this out and you got x squared times x to the negative 14, and then said that's x to the negative 12, and then made the exponent positive, you got that correct. You got that correct. Give yourself a pat on the back. Here's a try. Okay, I kind of waited to give you a shot at doing this before I explain. We've got a power to a power rule twice. So we're going to do them each independently. So I'm going to have x to the 8th times x to the 10th. And now we have the multiplication property. And the multiplication property says keep the base, add the exponents, and that's our answer. X to the 18th power. X to the 18th power. Okay, what happens when we raise a product to a power? So if 5y is a product, It's a product of two factors. However, we can look at this as 5y times 5y times 5y. So all of 5y is multiplied by itself 3 times. And then I can say, well, let me take all of the 5's and multiply them together. And I'm just reorganizing the y's together. So that's 5 cubed times y cubed. This is 5 cubed times y cubed. And 5 cubed is 125. And then y cubed just hangs around there, and we get 125 y cubed. The important part here, though, is to be able to go from here to here. So being able to recognize that is really important. And here's our definition or rule. For every non-zero number a and b, so our base cannot be 0. Our exponents are integers, whole numbers, and their opposites. Then ab raised to the nth power is the same thing as a to the n times b to the n. Every factor. You can also think of it as every base. Every factor in parentheses gets the power. So I think I've got a few examples where hopefully you'll be able to catch on pretty quickly. We've got 2x cubed. Highlighters really help. 2 is a factor, x cubed is a factor. That means the base of 2 is going to get the 4th power, and the base of x cubed is going to get the 4th power. So both bases get the 4th power. 2 to the 4th is 16, and x cubed raised to the 4th power is x to the 12th power. So our answer is 16x to the 12th. Here's another example, 2z. Actually, let's make this a little bit more interesting. So I'm going to make it just a little bit more interesting. I think I got white right here. There we go. There we go. Let's make this 2zy to the negative 2 raised to the 4th power. 2zy to the negative 2 raised to the 4th power. This time I have 3 factors, meaning 3 bases. So 2 is going to get the 4th power. Z is going to get the 4th power, and y to the negative 2 is going to get the 4th power. I can even put that 2 in parentheses. I love putting those factors in parentheses. 2 to the 4th is 16, z to the 4th times y to the negative 8. A power to a power, you multiply. We need to make that negative exponent positive. So y to the negative 8 becomes y to the 8th, y to the positive 8th in the denominator. And our answer is 16 z to the 4th over y to the 8th. Now I've got a few for you to try. So we're going to try this one. I know it says example, but I'm pretty confident in your ability to give this one a try. So think about how many parentheses you're going to have. Well, I've got a base of 4, and I've got a base of y to the 5th, so I'm going to have 2 parentheses. Parentheses with a 4 raised to the negative 2 power, and a parentheses with y to the 5th raised to the negative 2 power. And 4 to the negative 2, that needs to be simplified. So 4 to the negative 2 is going to go down to the denominator and become 4 to the positive 2. Leaving me with a 1 in the numerator. And then y to the 5th to the negative 2 is y to the negative 10th. The fraction is going to stay. 1 stays in the numerator, but y to the negative 10th needs to go down to the bottom with that 16, because 4 squared is 16. So we have 1 over 16y to the 10th power. Okay, here's another one for you to try. Go ahead and press pause. When you're ready to check your answer, press play. Okay, welcome back. I have 3 to the 4th power times x to the 0 to the 4th power. 3 to the 4th power is 81. X to the 0 is 1. And 1 times itself 4 times is just 1. So our answer is 81. Simplifying a product raised to a power. So now we're going to start putting more and more together. So we're going to have 2 bases. So I've got this base, x to the negative 2 raised to the 2nd power, and then I've got 3xy squared to the 4th raised to the 4th power. So I'm going to do this first one in blue. X to the negative 2 raised to the 2nd power is the same as x to the negative 4th. I'm going to do this next one in red. I have 3 bases, so they're each going to get the 4th power. So I have 3 to the 4th power times x to the 4th power times y squared to the 4th power. 3 to the 4th is 81. X to the 4th times y to the 8th. Power to a power we multiply. And then of course we have this original x to the negative 4. So I'm going to rewrite this with my coefficient out front, and then x to the negative 4 times x to the positive 4 times y to the 8th. Well, negative 4 plus positive 4 is 0. So 81 x to the 0 times y to the 8th. Well, x to the 0 is just 1. 81 times 1 times y to the 8th. Well, multiplying by 1 is the same thing as keeping your value. 81 y to the 8th. Would I expect you to go through all that work? Absolutely not. Absolutely not. I think that you would need to definitely do this step. And I think this step would be helpful as well. But from that step, I believe that you can go all the way to the answer. So maybe 2 steps and an answer. Okay, let's try another one. X squared cubed. We'll try and do that same thing. 2 steps and an answer. Times 3x to the 5th raised to the 4th power. So x squared raised to the 3rd power would be x to the 6th power. And then we have 3x to the 5th raised to the 4th. So one base is 3, and that's going to be raised to the 4th power. And the other base is x to the 5th, and that's going to be raised to the 4th power. Well, 3 to the 4th is 81, and then I've got times x to the 6th times x to the 20th. That would be 81 x to the 26th power. 81 x to the 26th power. Okay, I'm going to give this one to you to try. See if you can try this one. 2x cubed raised to the 5th power times 3xy squared raised to the 3rd power. Okay, I got 2 to the 5th, x cubed to the 5th, 3 to the 3rd, x to the 3rd, y squared to the 3rd. 2 to the 5th is 32. X cubed raised to the 5th power is x to the 15th. 3 cubed is 27. X cubed, and then y to the 2 times 3 is 6. So I have 32 times 27, x to the 18th power times y to the 6th power. Now off to the side, 32 times 27. I get 224 when I take 32 times 7. Now I'm going to take 32 times 20. And I get 864. So my answer is 864, x to the 18th, y to the 6th power. Okay, here's another one for you to try. This time I'm going to change it just a little bit. So this is going to be a negative 6xy raised to the third power times 5x to the negative 3 all to the second power. Press pause, and when you're ready to reveal the answer, come on back. So I'm going to have negative 6 to the third power, x to the third power, y to the third power, times 5 is a base to the second power, times x to the negative 3 is a base to the second power. Negative 6 cubed is negative 216. Hopefully you can do that as quickly as I can. X cubed, y cubed, because it's really going to help you. Times 25, 5 squared is 25, times x to the negative 6 power. So we have negative 216 times 25. That's going to be 1080 first, and then when I take 216 times 20, I get 0, 10, 4, 5. So I get negative, because I have that negative here, negative 5,400, and then x to the negative 3. 3 plus negative 6 is negative 3, y cubed. I'm going to make that exponent positive by moving that x to the negative 3 down to the denominator, and I get negative 5,400 y cubed all over x cubed. Now I'm not sure if you remember, I'm gonna show you one of these because I'm not sure if you remember scientific notation. 6.1 times 10 to the 9th times 8 times 10 to the negative 3. This is all multiplication. 6.1 times 10 to the 9th times 8. So I'm going to rewrite this as 6.1 times 8 times, and then we have 10 to the 9th times 10 to the negative 3. Well, we know 10 to the 9th times 10 to the negative 3 is going to be 10 to the 6th power. 6.1 times 8 is 48.8. Now, if we want to write this in scientific notation, I have to move that decimal so that my number in front of the 10 to the exponential power is a number between, so this number has to be between 1 and 10. Between 1 and 10. So 4.88 times, well, if this was the 6th power, I would be moving it 1, 2, 3, moving the decimal. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I think I counted that correctly. If I didn't, it's gone. And hopefully you know what I'm talking about. So I'm moving that decimal to the right 6. When I move the decimal left 1, I made my cause a little bit worse. So it's not 10 to the 6th. Now I'm going to have to move it 10 to the 7th. So we use our properties of exponents to simplify, and then we have to go back to that scientific notation. Let's go ahead and try this. 4 times 10 to the 6th, and write your answer in scientific notation, times 9 times 10 to the 8th. Okay, hopefully you gave that a try, and you're back. 4 times 9 came first, and then times 10 to the 14th power. Well, that's 36 times 10 to the 14th power. I need to, instead of going right 14 places, I'm going to have to move my decimal place to the left to put this in scientific notation, which means instead of 14 places, I now have to move 15 places to get to my final destination. 3.6 times 10 to the 15th power. And that concludes our lesson on more multiplication properties, which included, let's review, it included a product raised to a power, and it included a product to a power, and it included a power to a power. So lots of different rules that we learned in this lesson. Very important, once again, for you to get the practice so that you can have some excellent skills, some solid skills that we can build on